Hello class, this is Mr. Hart, and in this podcast we're going to talk about inverse trig ratios. And in the last lesson we talked about how we could take an angle and find a missing side. In this podcast we're going to go the other way and take a side and find a missing angle. Okay, and actually in this case we're going to need two sides to find a missing angle. Okay, so trig ratios helped us find sides, and inverse trig ratios are going to help us find angles. Okay, they basically do the opposite operator, right? They go the other direction. Okay. And that's why they're called inverse trig ratios. So an inverse trig ratio has a couple of different names. Okay, it's written a couple of different ways. But let's say we have this triangle right here, and we're trying to find this angle. Okay, so let's say we know sides A, C, and B, and we're trying to find the angle theta right here. Okay, well, instead of using a regular trig ratio, we're going to use the inverse trig ratios. Okay, and so there's two different names or two different ways to write it. Some people like to write it as arc sine. Okay, arc sine meaning inverse sine. Okay, and when you get into higher trigonometry, you'll learn why that's the case. But for now, just understand that's one way to write it. Another way to write it is the sine with this -1 power. Okay, kind of showing an inverse operation. Okay, so you'll see it written two ways: either arc sine or sine inverse. Your calculator may have one or the other. Okay, but it works the same way as a regular trig ratio. Okay, it's still opposite over hypotenuse for sine. It's still adjacent over hypotenuse for cosine, and it's still opposite over adjacent for tangent. Okay, but now it helps you find the angle instead of the side. Okay, so if I want to find theta, for example, this angle right here, okay, what you're going to do is you're going to go into your calculator, plug in sine inverse, and put in the values for A and C. Or you could put in the values for B and C and do cosine inverse, or you could do tangent inverse of A and B. Okay, and that will give you the angle. Okay, so if you have the angle, you need the sine, or need the side, you do a trig ratio. If you have a side and you need the angle, you do an inverse trig ratio. Okay, let's go ahead and look at an example problem to help us figure this out. Okay, so we want to find the missing angle theta, and we know that this side is 4, and this side, or the hypotenuse, is 5.66. Okay, so again, because we're trying to find the angle, we're going to set up an inverse trig ratio. Okay, so the angle in this case is going to be equal to, we have an opposite and the hypotenuse, so we're going to want to do inverse sine. Okay, so I'm going to write it this way: sine inverse of the opposite over the hypotenuse, right? And so that's going to give us sine inverse, in this case, of, sorry, let me write that better. That's going to give us a sine inverse of 4 over 5.66 in this case. Okay? And that shall give us that theta when we put it into our calculator. Again, like I talked a lot about last time, make sure your calculator is in degrees. But we do sine inverse of 4 divided by 5.66. And you should get, if it's in degrees, that angle is 44.97 degrees. Okay, and so again, on your calculator, make sure you can find the sine inverse button. Usually for like a TI-84, it's the second option on the sine button in blue. Okay, and so if you look where the sine button is in blue, you'll see the sine inverse button. So what you would do is you'd click second and then the sine button right there. Okay, did I hit it right? Nope. Second, and then the sine button gives you sine inverse. Then you just type in the value, 4 divided by 5.66, like that. Okay. And if you do that right, then you should get the value that you're looking for. Again, make sure it's in degrees. Make sure it's sine inverse, not sine. And if you press enter, that will tell you 44.968 degrees. Okay. That's the size of that angle. So we have two sides. We use an inverse trig ratio, and that gives us our angle. Okay? All right, let's do another one, just to make sure we got this down. So find the missing angles. Okay, in this case, we have all the sides, so we can use any of the inverse ratios that we want. We just want to make sure that we plug in the right numbers. Okay, let's use inverse cosine for this problem. Okay, so let's find this one right here. This Greek symbol is phi. Okay, so in this case, phi is equal to, let's do cosine inverse. Okay, so cosine inverse of adjacent over hypotenuse. Okay, and in this case, it's going to be cosine inverse of the adjacent side is 12, the hypotenuse is 20, so cosine inverse of 12 over 20. Okay, and that's it. We just got to plug that into our calculator. Again, make sure you do the cosine inverse option of 12 over 20. And you should get, when you plug that into your calculator, that you get 53.13. Okay? So that is the angle of phi. Okay? So this guy right here is 53.13. Okay, now there's two ways to find this angle that's left over. You could either use triangle sum theorem that says all the angles add up to 180, okay, to find that angle, or you could just do another trig ratio. Okay, let's just do another trig ratio for this case. So for this angle theta, we could say theta equals, again, cosine inverse of adjacent over hypotenuse. So cosine inverse of this times 16 over 20. And that, again, if you put in your calculator correctly, you should get that is equal to 36.87. Okay? So there you go. This angle over here is going to be equal to 36.87. Okay? Let's check our work last of all. Okay, 53.13 plus 36.87 plus 90 does give you 180. So yes, we did our problem right. All those angles add up correctly. Okay, but again, really simple, right? You find the opposite or in the hypotenuse or the adjacent hypotenuse, right? Whatever trig ratio you're using, plug in the cosine inverse, and that tells you the angle. Okay. Alrighty. Let's have you do one more problem for you to check on your own to make sure you got this down. So go ahead and pause the podcast if you need to, and go ahead and try this problem. See if you can find alpha and beta using inverse trig ratios. Okay. And if you go through that, you should see that the easiest one to work with will be tangent because you have the opposite and the adjacent. Okay. So let's find alpha first. So alpha is going to be equal to the tangent inverse of 8 over 5, right? Because opposite over adjacent. So that's going to be 8 over 5. Plug that into your calculator. 8 divided by 5. Tangent inverse of 8 divided by 5. You should get 57.99 degrees. And then if you do beta as tangent inverse, so beta right there, tangent inverse would be 5 over 8, right? So tangent inverse of opposite over adjacent. Opposite is 5. Adjacent is 8. And that should give you, when you plug that into your calculator, tangent inverse of 5 over 8 should give you 32.01 degrees. Okay? So if we were labeling this triangle, 57.99 degrees would be right here, and 32.01 degrees would be right there. And then again, we can check. Does 32.01 plus 57.99 plus 90 add up to 180? If you put that in your calculator, yes, that does. So this is the right answer. Okay? Alrighty, but that is inverse trig ratios, okay? So just make sure you, again, have your calculator in degrees. Make sure you're hitting the inverse button and not the regular ratio, and you should be good to go. But hopefully that all made sense. Let me know if you have any questions, and thank you for watching.